Good morning everyone. My name is Emertxe Krishna. Today I am going to present my embedded system project titled Microwave Oven Control System using PIC16F877A Microcontroller. This project was completed as a part of my embedded system internship where I designed and simulated a real-time microwave oven using embedded C programming. In this presentation, I will first explain the project purpose and goals followed by what I learned during this project. Then I will briefly discuss C programming, embedded systems, microcontrollers and the microwave oven working concept. After that, I will explain the PIC16F877A microcontroller, tools used, simulation results, key learning outcomes, and finally the conclusion. The main purpose of this project is to design and simulate a microwave oven controller system using a PIC microcontroller. The goal is to understand how embedded systems work in real-life home applications. Through this project, I aim to learn embedded system concepts practically, gains hands-on experience with microcontroller, implement real-time operations like time settings, start, pause and stop functions. This project helps in understanding how software controls hardware in appliances. In what I have learned in this project, through this project, I learned the basics of embedded C programming and how to control microwave oven functions using software logic. I used MPLAB X IDE to write, compile and debug the program. I also used PICSimLab to test the project without real hardware. I learned how timers works for countdown operations, how microcontrollers interact with input and output devices, how embedded systems are used in home appliances. Overall, it gave me strong practical knowledge in embedded system. C programming is used as the main controller language for the microwave system. In this project, embedded C control operations like setting, start, pause, stop and countdown. By this, it uses for conditional statements for decision making, loops for continuous operations, timer logic for accurate timer applications. C programming allows efficient and reliable communication with the microcontroller, making it ideal for real-time embedded applications. This project shows how C language is widely used in embedded systems for developing real-time applications. During this internship, I gained a comprehensive understanding C programming which is foundational to the project. I learned to implement core decision making logic using control flow statements like if, else and manage data with arrays. The training on the functions and pointers was crucial for writing modular, efficient and stable code which is necessary in memory constrained embedded systems. Furthermore, the introduction to and its object-oriented programming principles was directly applicable as the microcontroller environment is built on and interacts with sophisticated libraries that use classes and objects. This knowledge enabled me to effectively use pre-built libraries and understand the structure of modern embedded code. In this, what is embedded system? An embedded system is a specialized computer system designed to perform a specific task within a larger devices. It consists of hardware like microcontroller, memory and input-output devices along with software written mainly in C language. Embedded systems operates in real time and responds quickly to user inputs. They are reliable low power and cost effective. Examples include microwave ovens, washing machines, automobiles, medical devices, and industrial machines. Like continuous operations are required are applicable in embedded system applications. Microcontroller. A microcontroller is a small computer on a simple and single integrated chip designed to control specific operations in embedded systems. It contains a processor, memory, and input-output ports. The microcontroller continuously reads input signals, processes data, controls output devices. It is compact, low power, and low cost, making it ideal for home appliances and automation systems. They are widely used in applications such as microwave ovens, washing machines, automobiles, and traffic lights, and industrial control systems. Microwave oven. A microwave oven is an electronic kitchen appliance which is to heat and cook food quickly. It works by generating microwave energy which heats the food evenly in a short time. A microwave oven uses an embedded system to control its operations such as time settings, start, pause, and stop functions. The embedded controller processor uses inputs from buttons or keypads and controls the cooking process according to the programmed instructions. Microwave ovens are easy to use, energy efficient, and save time. They are widely used in homes, restaurants, and food industries for fast and convenient cooking. In this project, we are going to implement micro mode, grill mode, convection mode, and start mode. We use PIC16F877A Microcontroller. It is an 8-bit microcontroller developed by Microstrip technology and is widely used in embedded systems. It contains a CPU, program memory, and data memory, timers, and input ports on a single chip. It supports programming in embedded C and it is suitable for real-time applications. The microcontroller has multiple I/O pins that allows to interface with devices such as displays, keypads, and sensors due to its low cost, low power consumption, and easy programming. Is commonly used in projects like microwave ovens, home appliances, and industry control systems. PICSimLab. PICSimLab is a simulation software used to testing embedded system project without using actual hardware. It allows users to simulate PIC microcontrollers along with input and output devices such as switches, LEDs, and displays. PICSimLab helps in observing the behavior of a program and verifying its functionality. It is mainly used to find logical and timing errors in embedded C program. PICSimLab is very useful for learning, debugging, and validating embedded applications before implementing them on real hardware. It helps in observing system behavior, finding errors, verifying programming logic. Simulation results and demonstration. The microwave oven project was successfully simulated using the PICSimLab, which program developed in MPLAB X IDE. The simulation verified the correct operations of functions including time settings, start, pause, resume, and stop. The countdown their timer worked accurately according to programmed logic, and display updates were observed in real time. User inputs were correctly detected and processed by the system, demonstrating proper control flow and timing behavior. The simulation results confirmed that embedded C program performs reliable and meets expected functionality of a microwave oven control system without using physical hardware. Let's look out our project demo, what we done in this internship. Here we open the MPLAB X IDE version 6.25. It is a new version. Here we see the files .c files, .h files. These .c files are stored in source files, like clcd isr main.c, matrix keypad.c, microoven.c, timers.c, and header files like clcd.h, matrix keypad.h, microoven.h, timers.h are stored in header files. For our project, the required program was written for each module according to their functions. Let's see this. So let's check our program have any errors or not. Let's select clean and build for compilation. There is no errors in our program. We have different modules for different functionalities. To implement our project, after compilation of our program, we go to the PICSimLab to project demonstration. We select PIC board, and microcontroller is PIC16F877A Microcontroller we used in this project, and we select the clock frequency at 20 megahertz, and there are 4 modes as per LED we saw in our screen, like micro mode, grill mode, convection mode, and start mode. These 4 modes are working differently with their operations and functions according to our usage. Let's select micro mode. In this micro mode, the power is 900 watts. We used to select the time that shown in LED. Left side shown as minutes and right side is shown as seconds. We select like 30 seconds. We enter by using these numerical buttons, and for enter the values we have to select hashtag symbol. If we have to change any timing values, then we used to click asterisk or star symbol, then the numbers are resetted into 0. Let's select 30 seconds. We set the time for 30 seconds. We see that 30, we click that and enter. As we see that it decrements the 30 seconds, and the heater fan will be running. It means the microwave is working on for 30 seconds. In this we have 3 modes. We have to stop, start or resume, pause. If we want to pause, we select pin 5, then the process will be paused. If after pausing the process, if we want to continue or resume the process, we select 4 pin to resume, that means decrementing, or else pause. If we want to exit our operation, then we used to select 6th pin. So we used to select 4th pin to continue the process to end. Let's see. After that, time up and enjoy your meal, as message was pop up, like the food is heated, like that. And we select the grill mode. It is also same as micro mode, but different functionalities. We select 60 seconds here. enter. It again decrements the 60 seconds up to 0. From this time the microwave oven is working to generate heat in the microwave oven. In this we have to start or resume or pause or stop. If we want to stop the process, like we used to pause this process, we select pin 5. See, the fan is stopped, so we used to stop the process at while running. And if we want to run the process and again, we used to select 4th pin. Like we see that the seconds decremented to 0, gradually decremented to 0, and the head temperature is 27.50 degrees Celsius. If we want to exit the process of operation, we used to select sixth pin. Like if our food is completed and we have to exit, then we used to select sixth pin. We immediately exit from the operation to normal modes. And another mode is convection mode. For the convection mode, we want to select pin 3. In convection mode, it is different from other modes. In this, we used to select temperature. Before, we used to set timer. We select how much temperature we need to heat the food or something. Let's I put 60 degrees Celsius. From up to 180 degrees Celsius, we used to select in this temperature. I used to enter that option, and for our given temperature, it preheating the food or something we used in micro oven for up to 1 minute. For it's like a preheating like that. In this there is no pausing and no stopping process was done in this preheating process. It is independent from the manual operation. According to our temperature, it will runs predetermined with 60 seconds. After 60 seconds, we want to heat or we want to cook more time, then we used to select more time, then we heat the food. So after that preheating process, and again it shows if you want to implement more time or not, like that. I select 30 seconds. Three minutes, no. Wait a minute. I will close its structure. I will open again. File, load X file. we load the X file and we see the start mode by clicking 4 and the time is 30 seconds. In this, if we want to add 30 seconds again and again, we used to select pin 4. When we see that 16 seconds 15 seconds decrementing, if we want to stop, we select 5. If you want to pause, then select 4. If you want to heat more amount of time, then we click 4. See, 30 seconds is added to our last time. Like we see 25 seconds. Let's click at 20. It goes to 50. Like that, we used to add the time according to our wish. Like we add 30 more seconds after every process we want, like that. For 28 seconds, for 20 seconds I will again click the 4th pin. We see it goes to 50. See, it goes to again 50. That like this we have to increase the timer according to our usage by clicking the 4th pin in this start mode. So I stop the process by clicking 4, and this is our project demo by micro oven using PICSimLab of PIC16F877A Microcontroller. So in this project, in key learning outcomes, through this project I gained strong understanding of embedded systems, practical knowledge of embedded C programming, experience in MPLAB X IDE and PICSimLab softwares, understanding of microcontroller operations, problem solving and debugging skills. This project improved my confidence in developing real-time embedded applications. In conclusion, this microwave oven project successfully demonstrated the real-time applications of embedded systems using embedded C programming. It provided hands-on experience with PIC16F877A microcontroller and software development using MPLAB X IDE simulation using PICSimLab helped in accurate testing and debugging. Overall, this project strengthened my technical skills and understanding of embedded system design in real world appliances. And thank you for giving me this opportunity to present my project. I am happy to answer any questions. Thank you. In given comment section. Thank you.